So do A for a warm-up. There's the general alternate definition, which you should know. In this case, A is 1. Do you know that? Memorize? There, look out, like you know your name? Okay. Are we ready? Okay. So in this case we said x is 1 and the function is cubing. So it should be something like the derivative at 1 is the limit as x goes to 1 of x cubed minus x cubed at 1, which is 1, over x minus 1. Yay? Okay, I imagine there are two groups. Those of you who remember how to factor difference of cubes and those who don't. I can tell you, being an old person, that in 20 years, when you go to help your 10 year, whatever, when you go to help your kid with this, you probably will not remember how to factor a cube. So, what's a workaround? Say you don't remember how to factor a cube. What else could you do? Every fraction is also a blank problem. Division problem, yeah. So could you say, well, shoot, I don't remember how to factor, but I do know that I could take x minus 1, synthetic or regular? I could take x minus 1 into 1x cubed, no x squared, no x, and negative 1, and synthetic to get what I would when I factor this, which is to say this is the same as x squared plus x plus 1. It should be the same as if you factored and canceled x minus 1. So what is the limit? 3. Should you ever miss a definition of the derivative problem, given that you have a backup way to know the answer? What's the way to know the answer? Take the derivative by power rule. We know the derivative is 3x squared at 1. Its derivative should be 3. So there's no reason to miss this. All right. Today should be just practicing fine-tuning a big idea of calculus, and that is relationships between a function and its derivative. We'll do a little bit of big idea, a little bit of AP style practice, and then you'll do a matching kind of activity with your group of 2 or 3 or maybe 4. We'll see. All right, so big ideas of calculus. When a function is increasing, its derivative, blank, is positive. Graphically, it'd say the derivative, actually, graphically, it'd say if f is increasing, then the f prime graph is above the x-axis. Okay? When a function has a relative max, its derivative is changing positive to negative. That would mean that where f graph has a max, the f prime graph is doing something like this. Yeah? Crossing from above the axis to below the axis. Sweet. When a function has a horizontal tangent, its derivative is 0. Okay? Graphically, you'd say where f is flat, the f prime graph must be where? Or what?
0.
At the x-axis, which is to say 0. The derivative is 0, yeah? When a function has a vertical tangent, its derivative is undefined. That would mean that where f is vertical, the derivative does not exist. Doesn't even have a point. But it probably goes to infinity. Because as f gets more and more steep, the derivative gets bigger and bigger, so f is probably going to infinity. You follow? All right, now, this is then a pretty typical problem. Would you put these three big ideas, f increasing, f prime positive, f decreasing, f prime negative, f flat, f prime 0. Okay? Now, we're going to go using those in one direction when we make a graph relationship. So here, in this case, they said this is the graph of f, and I want to graph f prime. Now, when I go that way, there's two totally different ways of thinking here, depending on if they're giving you f or f prime. When they give you f, and you want f prime, then you're saying, where is this increasing, decreasing, and flat, and use that to say where's the derivative, positive, negative, 0. So we're going this way in that first one, all right? So I think you'll agree that f is increasing up to 2, so that means the derivative is positive. Here, the graph goes flat, so there the derivative is 0, and then later the function is decreasing, so the derivative is negative. I could also draw baby tangent slopes there and tell me the same thing, yeah? So if I were to graph this, I would want to graph something that is 0 at 2, and positive before and negative after. Question is, what shape? What should I something like that? Yeah, I mean, that wouldn't be bad if it was multiple choice, because at least it would tell you, hey, you're looking for above, 0 below. But come on, this is negative x squared, so its derivative should be negative x-ish, yeah? So it should look something like that. Now, would you do the one below it using the same kind of thinking? You're given the graph of f, and you're to sketch f prime. When you're going that way, you say, where f is increasing or decreasing or flat, if the derivative is positive or negative or 0. Ready? Where's the graph of the derivative 0? 0 and 2 point, whatever that is, 2.8-ish, yeah? Okay? Left of 0, the function is decreasing, so the derivative is negative. Between 0 and 2.8-ish, the function is increasing, so the derivative is positive. Then it has to hit the 0, I missed. And then after 2.8, the function's decreasing, so the derivative is negative. Power-wise, does that kind of jive? This looks like a what graph? Negative x cubed, so does it make sense the derivative would look negative x squared-ish? Yeah. All right. Now let's switch gears and go the other way, and it is very much a total change in thought process. Now, we are on this right-hand side, they're giving you f prime, and you want to say, what does f look like? Now, because of that, you're going to change and say, all right, this time I'm taking this and going that way. Where the derivative is positive, f is increasing. Where the derivative is negative, the function must be decreasing. And where the derivative is 0, the graph goes flat. So, I'm going to start by saying, all right, I want to look at the signs of the derivative. So here, the derivative is negative. So that means the function needs to be decreasing to 0. Now the question is, where do I draw it? Do I draw it here, or here, or here? Well, that actually is up to you. That's really, whether you know it or not, that's the plus c when you integrate. You don't really know where it is vertically. There's this gray area. So it doesn't matter where you start. Just make it decreasing to 0. At 0, the derivative is 0, which means the original function goes flat. So go flat. From 0 up till, do I care about up to 2, or do I need to go all the way to 4? All the way to 4. The derivative is positive all the way to 4, and so because the derivative is positive, the function needs to increase all the way to 4. Now, if you're thinking what's significant about that point, surely that's something. All that really matters is that's the greatest derivative, which means that's the steepest slopes here. So 2, I guess if you wanted to attach significance to that, you'd say that's where the graph is steepest. After that, the derivative is 0, so the graph goes flat at 4. Then the derivative is negative, so the graph of function decreases. Does this match power-wise? If f prime is negative x squared, then f is negative x cubed, 1 power greater. Yeah. All right. Try that same thought process here. On the one below, you're given f prime. Look where it's positive, negative, 0 to say where f is increasing, decreasing, flat. Okay. Ready? All right, the thought process goes where the derivative is positive, negative, 0, then the function is increasing, decreasing, flat. So, wouldn't you say that the derivative is positive here, so the function needs to do what up to 0? Increase up to 0. At 0, the derivative is 0, so the function must go flat. Then the function starts to decrease or goes back to increasing? Yeah, the derivative is positive, so it goes back to increasing. Does it keep increasing to 2.9, or does it keep increasing all the way to 4? All the way to 4, where it goes flat, and then it decreases. That feels like negative x cubed, resulting in negative x to the 4th. 1 bigger in power seems logical. We're good to go. All right, let's talk this idea in a table form. I got this table of x and f of x values. That should be little f. It had an automatic capitalization on it. This should be little f. Where must f have a horizontal tangent? Now, the first thing I would hope to find is to say, well, there's a horizontal tangent where the derivative is 0. Well, that would be great. They don't give me the derivative, so I can't go looking there. And, okay, so now what is it? So, all right, so maybe, if you get stuck, then say, well, maybe it'll help to graph this. 0, and it doesn't have to be pretty. 0, 2, 3, 8, 4, 3, 5, 1, 8, negative 7. Maybe the graph of the points will help illuminate. Now, keep in mind, the biggest danger on a table is reading too much into the table and not thinking of all the possibilities between the points, right? It's not a connected dots exercise. So, give me a ballpark. Is it true that there's a horizontal tangent at x equals 3? This is the key word here. Must there be a horizontal tangent at x equals 3? No. Why? It seems like that's the highest point. Why isn't that? Yes, that's the horizontal tangent. Yeah, it could have been higher earlier. It could have been here. So by that thinking, could I say there's a horizontal tangent in 0 to 3? Must there be a horizontal tangent in 0 to 3? Okay, how could there not be one in 0 to 3? It could be still climbing after 3, like this. Okay. What about then a horizontal tangent in 3 to 4? Okay, now we're talking. Now, I can't say for sure 0 to 3, nor can I say for sure 3 to 4, but can we say for sure 0 to 4? Yeah, and that's, in essence, it's because the function went increasing to decreasing between that interval. And so surely, if this is continuous, which I know it's continuous because it's differentiable, then it has to have had a max in there, which means max could be this or this. That's why they're giving me differentiable. They're saying it's got to be a horizontal tangent because it's differentiable. So when it hits that max, it must be that case. So I would say that's true. Okay, you with me? All right. Now then, I am going to give you either in 2s or 3s a group of 24. Yep, sorry. I don't even know if you have to. It would probably be. It was a multiple choice, so I should. So yeah, that was better. All right. 2 groups or 1 group? What do you want to do? Okay. All right. Would you please, when you get these cards, would you 2 groups? Okay. Would you clip these, and you need to separate these into function and derivative. You should have 2 columns of 12 each, and you will be matching the function to its derivative. So feel free to get out of your seats and walk around, or not walk around, but stand around, whatever. 12 in each column. The problem is that some of these don't have a label. My bad. So I think 2 of these cards don't have. Hey, hi. My bad. I just skipped your group. Sorry about that. I just assumed you guys would kill this so much it would give it. All right. So you're putting either function on one side and derivative on the other, and then your goal is to match the function with its derivative, pair them up. At the end of the day, you should have 12 pairs. You should have 12 in each column.
I'll leave those off to the side. Derivatives on that side. You need 12 of each. You should have 12 of each column.
You should have 12 of each. If you get something unlabeled, use that as a guide. 12 function, 12 derivatives. Tom, you want to double check the work? Yes, you do.
Yes.
You trust him?
Trust them.
That's foolishness. When you get done, you may work on homework tonight or homework last night. We'll go over these in a minute. Good. Just more fun homework. How's it going? How you doing? Something here? Does it hurt? Did you see the pictures? No. Really? Like X-ray? Is it
Oh, really?
Throw,
Wow.
Are we ready?
yeah.
No? Yes? Almost? Couple? We're working? Couple more minutes? Besides the obvious slope ideas, some other ideas, domains should match.
You went with no columns.
Okay, let's go 2 more minutes.
I know, I'm sick. I wanted you to be like the energy of life. Alright, when you're sick, you're sick. Okay. No, I just want to make sure you were not depressed or something.
Okay, let's go. Would you real quick check these or check your partner's work? And if you missed one, feel free to blame it on your partner. Here we go. Oops, wrong one. So this guy, the thought process or my thought process might be something like this. Wouldn't you agree that this function is increasing, non-existent, decreasing? So the derivative should be positive, non-existent, negative, yeah? So for that one, did you get a match of something like this? This is the derivative for this graph. Do those two go together? Okay? Over here, the easiest way to do this would probably be, say, parabola derivative should be linear. That's probably the easiest way to go there. Okay? 2 for 2? Okay, put them off to the sides. Just as you find matches, stack them up all at once. Come off to the side, okay? Yes, I will ask you to shuffle later. Thank you. Okay, so this one, wouldn't you say that this function is increasing, flat, decreasing? So aren't I looking for a derivative that's positive, 0, negative? That could be a lot of ones. So this one would fit the bill. You could also go one better and say, hey, it's really flat there, so the derivative is small, and flat there, so the derivative is small. But those two go together. You get those two. Okay, this one, I use domain first and foremost. This has no points on the negative side, so I need a derivative with no negative values. Then it was always positive, so I need a derivative that's always positive. Oh, sorry, it's always increasing, so the derivative needs to be always positive. Domain helped me narrow that one down. Cool? This guy, this is always decreasing, so you want a derivative that's always negative. This one is the wackiest one. This is an absolute value graph. When you take the derivative of absolute value, it's a piecewise function. This one's kind of funky, but there's this abrupt change in slope. What would you say about the derivative at 0. The derivative at 0 does not exist, and that's because the slope went abruptly from negative something to positive something. If the derivative isn't continuous, then the derivative doesn't exist at that point. Anyway, it's a piecewise function. Did that go okay? Cool. This, you could have gone cube as square, but unfortunately I think there are 2 cubes and 2 squares, so you had to have said something like flat spot on the negative side and the positive side. So you look for a parabola with zeros on the negative side and positive side. So the cube, there was a little wider and bigger, I think. Looks like that. Yay? This, the easiest way is to say the derivative of sine is cosine. Some of these were hard because they weren't labeled, and so I had people in the last class have these upside down, and they were getting confounded. So that was probably difficult. But the intention was this guy had 3 flat spots, and the derivative would go negative, positive, negative, positive. That then is a cube. And then this one, this should go with x to the 5th. This is x to the 5th. It should go negative, 0, positive, 0, negative, 0, positive, 0, negative. 1, 2, 3, 4 zeros. That's this guy. You need to have 4 zeros. X to the 4th is the only one with 4 zeros, I believe. And domain says nothing on the negative side and negative, 0, positive. That should go with that. Negative, 0, positive means a graph that's below, at the axis above. And then this is always positive, and it should be small slope, so close to 0, a little steeper, and then back to close to 0. So that's all right. I think that's all. How'd you do?
Fantastic.
Excellent. Would you group them all together, shuffle them a little up, and paperclip them back together, please? Shuffle them, and then get out step 44 for question.
Number 2.
2. Maybe 25 and 24 also, maybe? 24, 25, and 2. Shuffle off the buffalo. Off again, shuffle. Come on, Cole, let's go. Move it. Hold it.
Gosh, Cole.
Hold it again, Cole.
Evan. Gosh.
Probably just have to take the test for somebody. Just for the future. Oh, there's some people also running service right now.
I'm sorry. I thought shuffling and everything, so I thought maybe
Thanks, sir. All right. Real perfectionist, really.
I'll get back to you.
All right. 25. 25 is 2 concepts. This would be an ideal free response problem next week on the test. The idea is you're trying to find area under the curve using infinite rectangles, but also interpolate what area under the curve means. So this then, part A, normally I do rectangles this way, but we have talked, and we'll continue to talk, that we should always go function specific. So in this problem, is there a delta x? No, there's a delta t. It's change in time. And is there a function f? No, the function is v at different times. So instead of x sub I times sub I. Okay, so use the function at hand. In this case, what is delta t? 6 over n. And the velocity I'll name in a second, but t sub I, remember it's where you start plus how many deltas you go over. In this case, you're starting with 0 and going 6 over n over I times. I is the counter of how many deltas you go as you go right in the under the curve. So when it's all fairly clean, I hope that you are having 6 over n out front for delta t, and 6I over n is inside the function. Now the function, be careful. Oops, I need to slow myself down. Wouldn't you say that the function says square it plus 1? And so what goes into the square it? 6I over n. It's important that you get the function kind of nailed down so that you have the 6I over n in the right place, and the squares in the right place, and all that stuff. All right. How many summations do you anticipate here? 2. There will be 1 here and 1 there. It's not like a binomial expansion like the other one because I didn't have a starting point besides 0. I didn't need to do that stuff here. So in the first one, what can I pull out altogether? 6 over n from this guy, and what else? 6 squared over n squared, and inside stays I or I squared? I squared. All right. On the second distribution, what can I pull out front of the summation? 6 over n, and what stays in the summation? 1. All right. You follow? Okay, so this one is 6 cubed, or 216, whatever you want. 216 over n cubed. The formula for squares, I remind you, I'll always give you those. For now, just use your notes, but I'll give you them on a test. That's that long formula there. What about the ones? What does 1 added to itself n times come out to? N. All right. Am I done? Is that the end goal? No, the end goal is to now say what does the limit approach as the number of rectangles goes to infinity. And we take the number of rectangles to infinity by virtue of a limit. It's the infinite limit. Says the first one goes to what? 216 times 2 over 6. Don't forget that 2 there. That's often forgotten. And that's 72. Okay. And what about the other part? 6. So the perfect area is 78. We? So that's part A. Part B says, all right, in this case, what did you find? Well, each calculation was a delta t. What are the units on delta t's? Seconds. So each delta t was really a little time interval. Hey, for 1 billionth of a second, the velocity was whatever in feet per second, yeah? So every tiny micro calculation, you're doing a little rate times time and getting a little feet, a little distance, or a little displacement. Now, later on, I'm going to get very picky about distance or displacement. In this case, it's actually both, because it's just always moving forward. So I'll take either. But this represents, so the area under the curve represents what? Is the distance or the displacement? Is the distance or the displacement? It's always displacement under V, but sometimes it's also distance, depending on if it's always moving in one direction. In feet from time equals 0 seconds to time equal 6 seconds. Another way to interpret the answer is to say, in 6 seconds, I traveled, car traveled, 78 feet. Right? Okay. All righty. 24. 24 is something else. Oh yeah. Okay, cool. So, you're home and you're about to make cookies for your math teacher, and you turn on the oven, And because I wrote a dumb model, I said that the temperature for the first 10 seconds is 30 T. Now it's linear, it's fine, but the problem is that I didn't give a y-intercept, so that's kind of stupid. That's assuming that the oven starts at 0 degrees. Wow, your house is really cold if your oven is starting at 0 degrees. But it goes up continuously for 10 minutes. At 10 minutes, if it goes up 30 degrees every minute for 10 minutes, then at time 10, it probably reaches a temperature of...
Good morning, Devlin Jaguars. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So now the oven's going to kick on and off, trying to keep the temperature around 300 degrees. So it will drop and then kick back on, drop and kick back on. So the point that is...
Hey, Jack, do you have a younger sibling that would like to join the Junior Jack Mickey Cheer Camp? If so, stop by the main office and pick up the form. The camp is Monday, October 14th to Wednesday the 17th. It's spooky season, Jack. You know what that means. They'll learn Trick or Treat Trees on Friday, October 18th from 6 to 8 with an improv show afterwards at 8:30. All participating clubs, please make sure to collect candy and leave it out. Enough time to make decorations. Spread the word throughout the community so we can have another great turnout. Contact Miss Ford if you have any questions.
There should have been brackets around that
Have
last
you ever wanted to
part.
watch 8 people all fall in love in a mysterious forest? Come see the DHS Fall Play Shakespeare's As You Like It. Buy tickets at lunch or at the door for $10.
So the line leaves off at 300.
But there's $2.90. The play is on the
So
10th.
the sign this way needs to pick up at 300.
Dad, this Wednesday through Friday is the last chance to pick up any ordered scrunchies from the DHS cheer team. Stop by any time during
So
lunch.
did you get K is 290?
Go, Jack.
Yes?
Today, counseling meet Hillsdale College is located in Hillsdale, Michigan. They are known for their classic clubs this day. Also, the University of Colorado from Greeley will be here. They are known for their teaching and nursing degrees and many more. Tomorrow will be Colorado College and Miami University. Because of the weather forecast, Boys District has rescheduled the egg drop for November 1st. This Friday, we want you to bring your favorite indoor game to play with your mentor or mentee in your room. Informational meeting is this Friday, 7th hour in Mr. Powers' room, West 102, for the Global Glimpse Summer Leadership Program for juniors. Make sure to ask your teacher for a nomination. 16-day trip for as little as $500. Picture retake day is today. If you missed picture day, stop by for your photos will be taken by noon. If you are wanting to retake your pictures, you need to bring the other purchase packet back.
Make sure you interpret it.
Juniors, next week on October 16th,
Interpreting a derivative is the rate of change.
Pre-bubbling for L through Z is
Interpret
today
positive
during 7th
negative.
hour. Contact Mr. Watson or Mr. Willie with questions. Attention Interact Peaceful School students. Report to Mrs. Sooner by start of 7th hour. Attention high school students that are members of the Student Advisory Group. We will have our first meeting today during 7th hour in room E100. Chick-fil-A is hiring at 2 locations, Aspen Grove and Kipling at C470. For more information, stop by counseling or check the bulletin board outside the cafeteria. Dazzling Jack, thank you softball fans for support yesterday at the seniors' last home game. You were awesome. Good luck to the ladies today in their last game at Golden. It's time for your daily day of the day. Happy National Nanotechnology Day, because it's 10/9/19. 10 to the negative 9th power. Have a great day, Jack.
Alright, so surface area, wouldn't you say that that's 2 area of the base, so 2x squared plus perimeter of the base 4x times height is y? But it says in terms of x only, so how do I sub in for y? Well, that's where this guy comes in. Y is 27 over x squared. So if you put that in place of y, that gives you an x only equation. And you can... what? It doesn't even say use calculus? That's stupid. Okay, so I guess you're finding the minimum surface area with a calculator. What did you want calculus for? If you didn't want to calculate, whatever. Okay, so now you can find them in technically you should be looking for where A prime goes negative to positive means, but whatever, they say calculate. Alright, any other questions? Cool. Have a lovely day. It's a great day for doing some math, and it's a great day for sip.